Thanks everybody for having me, and thanks for coming. It's really a pleasure to be here. I've had a fantastic week in Singapore. It's been a couple years since I've been here. I used to do quite a bit of business, but took a little bit of a hiatus. What I'd like to do today is start off and give a little bit of an introduction to some of the challenges, like the title says, associated with dealing with this new world of big data. And then talk in particular about a technology that we're harnessing as a company called R. And then what I'll do is wrap up and share some of the ways that this technology is being really utilized by very innovative small and large companies to gain some pretty significant competitive advantage, and what that means for them and what that means for the industry and how they're changing, competing in this global environment based on data. So by way of introduction, our company is called Revolution Analytics. We are a US-based company, but with partners around the world. And our partner here in Singapore is led by Lawrence Liu, and it's 1 degree north. So for anybody that has any follow-up questions, discussion, interested in R, the technology of big data, please feel free to contact either myself or Lawrence in particular. So our company, we are the provider of an open source statistical computing language called R. So before I dive in, let me just kind of get a feel for who our audience is. Is there anybody in the room here whose job is business analytics or data analysis? Okay, so that's one. Okay, very good. Is there anybody here who is in IT or managing data centers, things like that? A couple. Okay. Anybody from the financial services industry? One. Life sciences? Manufacturing? Telecom? Healthcare? A couple. Students? A few. So what did I miss? What does everybody else do? Give me a few. Throw out a few things. You guys are really shy. Somebody's laughing at me. So tell me what your job is since you're laughing at me.
We're looking at smart cities.
Smart cities?
Yeah, trying to see how analytics can.
Okay. Great. Fantastic. Very interesting. I should have mentioned government. That's really helpful. Let me ask this. Has anybody here heard of R? Okay, so that's a pretty good show of hands. Has anybody here used R in their job? Okay, a few. So that's not too bad. You seem shy. You shouldn't be embarrassed about it. What I hope to do by the end of this is to make you guys feel like the most popular people in the room. Okay, because what's happening, and I'll kind of share this with you. What's happening in the States is data analysis, data analytics, especially centered around R, has become remarkably popular. And I'll talk about why and what that means and the trends for some of the jobs and what it means for people. But anyway, so for those of you who don't know, R is an open source statistical computing language. The easiest way to think about it is to think about it if you've heard of something called SAS, which is a very, very large company based out of North Carolina, provides data analysis software. R is somewhat like an open source version of SAS. And people think about Revolution, and some people call us Red Hat for stats. So the analogy to think of it is R is similar to SAS, like Linux was compared to Unix, for example. Okay, and what our goal and our job as a company is to help commercialize it and drive this very popular technology, which has begun to dominate in the research and teaching world, and help bring it into mainstream enterprise commercial use. So you guys have probably all heard this, especially being here in Singapore. There's tremendous initiatives around business analytics and harnessing this trend around big data. And especially, we're based in Palo Alto. My office is right on University Avenue, Palo Alto, across from Stanford University. It's a very hot place for startups, lots of venture capital, lots of innovative companies. Our office is actually the former Facebook office before they moved out to go down the street. Everybody wants to talk about the explosion of data, about big data, about what this means, that there is this thing called digital exhaust. And think about what that means. It means, gee, there's all these systems out there, smart sensors, grids, web logs, cellular phones with tracking devices on, generating this data. But it's going out there into the ether. And it's sitting out there and it's not really being harnessed. And what there's tremendous opportunities to use this data to get things like cost savings, to get things like competitive advantage, to get efficiency improvements, to get higher profitability. And so what's happening is, in the startup world in Palo Alto, there's tremendous funding that's being put into big data startups, storage architectures, things like Hadoop, things like modern databases, things like NoSQL databases, things like cloud computing. But that data storage and those architectures don't give you the whole picture. Okay? And this is a relatively new quote that came out recently that I particularly like. And it says that companies, big companies, with massive amounts of data, but little clue, meaning little knowledge of how to harness that data, are being in the process of being disrupted by little companies with little amounts of data, but lots of clue. And what this really does is it sets up the need and it sets up the opportunity for startups of people with smart people that can do advanced analytics, even if they don't have massive amounts of data, like a Google or a Facebook, to start businesses, to become innovative and compete on a much grander scale than they normally would be able to. So what we see is really three challenges facing mainstream companies. And again, having spent a week here in Singapore, I've heard all three of these time and time again that need to be addressed to truly harness this big data revolution. The first one is that these companies need access to advanced tools to be able to extract knowledge from this data. And that knowledge and extracting that means not just looking at summaries, not just looking at backwards data, but being able to use complex mathematical techniques to gain deeper insight into what your data is actually saying, but also to be able to make forward-looking predictions. And that's where it becomes remarkably important and remarkably powerful to use your data. Not just to say what happened in the past, but why things happened in the past and what will happen in the future. The second major challenge that many of these companies face is they need to attract, retain, and develop analysts who are capable of using these tools, of developing advanced analytics techniques based on top of these platforms. And one thing that I hear over and over again from CEOs, from CIOs, from CTOs, is that they face this massive talent gap. A gap between people who can use these tools and what they need to be able to address the needs of their business. And so like any kind of supply and demand imbalance, what's happening is these data analysts, what I'll talk about in a minute or two, a data scientist, is the new hot job. Hal Varian, he was kind of chief scientist of Google, was famous for a few years ago saying, statisticians, or to be a statistician, is the next sexy job. Well, today, that's this thing called a data scientist. And what happens is it is the hot job in the U.S. right now, the most demand with the highest rising salary in the U.S. So very interesting. I'll talk about a little bit what that is and why that's the case. And then finally, the last piece that's very, very important is the ability to disseminate knowledge out of these advanced models, leveraging this data throughout the organization. And that's so critical because doing this analysis, leveraging this data, is no good if you keep statisticians and keep the analysis in a corner. You need to be able to take it, you need to put it in the hands of decision makers to allow them to change the direction of their business, to be more cost competitive, to change their product development strategy, to look at their customers in a different way. And we need to create a bridge between the people who know how to do that and the people who are making the decisions. Okay? So what we've been really focused on as a company is taking this base technology called R, which is really an ideal solution to each one of these three needs, and driving it into mainstream corporate use. So we have a few R users in here and quite a few people that have heard of it. But for those of you who have not, let me describe a little bit about what it is. Because R is a number of different things depending on who you are and what your perspective is. But at its most fundamental level, R is a statistical programming language. It was a language that, as the creators like to say, was designed by statisticians for statisticians. And it's very important to think about, and there's a couple of things in there. It is a statistics language, meaning it was designed specifically for the way statisticians think. But at the same time, it's a programming language, and of equal importance, it's an open source programming language. And what's happened as a result of that is it's fostered this community of developers, many of whom are academics and researchers, who are the leaders in their fields, whether it's in things like economics, biostatistics, finance, other areas of the life sciences, social networking, who are using this tool, using this platform to develop capability and solutions to solve data analysis problems. So it's also this ecosystem, much like Apple has, App Store. R has something called packages. Think of them as little applets or applications to solve specific data analysis problems that a researcher, that a company, that an analyst can use, can take, can build upon, and solve his problems. And then finally, the last thing that encompasses R that's of equal importance is it is a very powerful, probably one of the most powerful and flexible visualization tools existing in the world. And the one that I really like to use to illustrate that, there's a couple different ones I splashed up here. But this one I really like, and this is a chart from Facebook. Facebook is a heavy user of R. And they created this world map where they took every two people who was friends on Facebook, and they put a white line between them. And what do you see by doing this? You can look at this, and all of a sudden you can see, well, gee, I can see where the heaviest usage or the heaviest concentration of Facebook users is. You can see sort of the eastern U.S., you can see Europe, you can see Singapore, and then you see sort of a black spot up above. And it's a different way, it's a different important paradigm of data analysis, is not just to use the math and algorithms, but to enable people to use their eyes and their brains to discern signals. So I hinted earlier about the popularity of R. This is some work that's been compiled by a professor in the United States. And what the top graph illustrates is he's gone back and he tracks the statistical package that is cited when academics publish a research paper related to statistics. And what you can see by looking at this, over the past 5 years, R has really come to dominate. It's grown wildly, while all of the other tools have shrunk. Well, the impact of this is twofold. First is it's what the students are being exposed to. It's what these professors are teaching their students in terms of learning statistics. And what that's doing is it's creating a workforce of new analysts coming out of these universities into companies and bringing this thing called R with it. The second impact is equally important. And on the last page, we talked about packages, those applets or applications that are used to solve these problems in bioinformatics and finance, et cetera, et cetera. And what this chart is, this is a trend chart of how many packages have been available out there on the internet for people to use to solve these problems. And when I had done this chart and originally created it a few months ago, the number stood at about 2,500. Today, that number is actually 3,500. It has been and continues to grow exponentially to create functionality and capability that's unmatched in the statistical world. And I particularly like, and I think it's very powerful, to listen to other players, other providers of statistical software, say how important R is. And it's related to this. And what they say is they say R is important. It's an important complement to our software because the newest, most innovative techniques are available there first and faster than we could ever develop. So I hinted earlier at this thing called a data scientist. Has anybody ever heard of this term before? Nobody's heard of it. So I'll come back and I'll ask later another question. But about 2 weeks ago, what's called the Joint Statistics Meeting, I think it's called, JSM, is the worldwide gathering of statisticians. It was held in Miami. And we held a survey there. And amongst other things, we asked them a number of different questions. But one of the things that we asked was, there's this controversial term, this thing called a data scientist that people are starting to use. And we thought we'd ask these statisticians, do you consider yourself a data scientist? And you guys can see the result here. The answer was overwhelmingly yes. Well, what is this thing? And why do they think that's the case? Well, a data scientist is really a combination between a statistician who knows some programming or a programmer who knows some statistics. Who deals with data, who obtains it, who cleans it, who restructures it, who explores it, who visualizes, who analyzes, interprets it for their customers. Okay? And this is very important in this new regime of big data, where people are no longer working with simple legacy tools on their desktop. Where dealing in a big data regime requires new techniques, new capabilities, new infrastructure that can only be harnessed by being a data scientist, by being able to both know statistics and know programming. So now I'm curious, with that definition, is there anybody in this room who's a data scientist? Okay? You don't have to be shy, you can smile. Right? You're very lucky. You're going to be in one of the hottest job categories in the next 5 years. But a big part of, I think, the opportunity associated with big data and the rise of R is R has become the data scientist tool of choice. I'll share at the end of this, I'll share some case studies of how innovative companies in the U.S. are using this tool. But companies like Facebook, companies like LinkedIn, companies like Google, what they're doing is they're setting up these analytics center of excellence. And what they're doing is they're hiring people in with this title, and they're appointing chief data scientists to run these analytics center of excellence to develop and create innovative new methodologies to really change the business world with their data and with these methodologies. Okay. And actually, just last week, I didn't get a chance to roll it in here. There was just a new article, you guys can look it up in Forbes magazine, talking about how, once again, this is the hottest job category with the fastest growing salary out there. So, very exciting. So what do these guys do, and what role do they play in a company? If you look at the way data was traditionally, who's laughing at my pictures? Right? You don't like the IT person? See? IT person in the U.S., right? But there's traditionally been a sort of a gulf between two groups, between the IT organization and between the business organization. And the IT guys on the top, their job is to set up the infrastructure, to store the data, to structure it, et cetera, et cetera. And they know that. That's their life. That's their expertise. And then meanwhile, there's these guys on the bottom, right? These business guys who know some finance or they know some marketing. And they're trying to get information that the guys on the top have stored, and they feel like it's a little bit held hostage, right? And so there's been a movement for 10 years or so to try to do things like business intelligence, right? And create charts and graphs and things like that, provide data to these guys. But it's given some information, but somewhat limited, because there's still a gulf in between. The people filling that gulf are these data scientists. Okay? Their job is to create a bridge between the guys on the top and the guys on the bottom. Is to be able to take and understand and know that data architecture, what is in there, how it can be used, restructure it, do those things we talked about on the last page. Create models, create insights, and then be able to deploy them and provide it to guys down on the bottom such that they can make actionable, business-driven decisions. And that's the opportunity for big data plus analytics in companies, is to bring those together to drive these decisions. Is that what you do? Pretty good. So, as a little bit of a side, let's have another debate. There's lots of debates, and there's lots of overused terms. Analytics is one term that I think is overused and we have to define. But another one that's remarkably confusing, it means a lot of different things to a lot of different people, and people use in different contexts, is big data. And so the question is, what is big data? Well, big data could be big files, big structured data. But then the question is it a gigabyte? Is it a terabyte? Is it a petabyte? I don't know. It depends who you are. If you're an analyst working on your desktop or your local machine, a couple gigabytes could be a big data file. But if you're somebody like, I'll show later on a case study, the company called Zynga, I don't know if you guys know Zynga, it's an online gaming provider, actually generates 25 terabytes per day of user data that's generated from people playing their game that they need to figure out how to use. Well, there's another company in the U.S. Called Comscore that tracks web stream and click data. They generate on the order of a petabyte per day. Okay? So think about that. It really makes your eyebrows go up. Think about dealing with and analyzing all that kind of data. However, there's a different camp of people who say really big data is about unstructured data. It's about dealing with things like web logs, or text, or voice, or video. And that's got a really different set of challenges for analyzing and understanding what's there. But then finally, the one that a lot of people forget about sometimes is big analytics associated with big data may not just be the size of the data itself, but it could be the size of the model. Okay? And this means things like computationally intensive analyses, things like doing genomics research. When the people who do genetic sequencing and want to understand something called genome-wide association studies, they need to do multiple millions of calculations just to do one analysis on a small data set. It could be things like simulations, or it could be models with many, 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 many parameters. Okay? So you could think of something like a financial institution or a hedge fund that wants to develop a factor model to do its high-frequency trading. And they want to put in hundreds or thousands of inputs. Okay? That's a big model. I think that the way that I like to think about it, though, is that I like to say big, just like beauty, is in the eyes of the beholder. Okay? It depends who you are and what you're trying to do. But the one underlying theme, even though we've got all these camps who say big data is something different, they give a different definition, the one thing that we can get them all to agree upon is that big data is anything that cannot be analyzed with the legacy tools, where the legacy tools are both the hardware as well as the software. And they really have expressed a lot of unhappiness with the state of the tools to be able to do this. And so what we need is we need to develop advanced techniques both on the hardware side, on the infrastructure side with things like distributed computing, with things like MapReduce and Hadoop, but also on the analytics side to be able to address this challenge. So let me reorder a little bit and go back here. Why does this all matter? Right? Why should we spend any time going through all this trouble of storing this stuff, of structuring it, of trying to figure out how to analyze it? Because in some senses, a lot of statisticians, did I ask this? I asked people who were data analysts. Is anybody a trained statistician in the room? Let me ask that. Okay, good. You guys would be nice to me. But a lot of statisticians, one of the principles of statistics is that you don't actually need to use all your data. And so there's an academic debate or an academic argument going on about what's all this hype around big data. Statistics was designed such that you don't have to use it all. However, there are some very compelling arguments and value that can be achieved from actually using all of the data that you have. Probably one of the most important is to be able to relax certain assumptions in your models. Okay? So many models and statistical models make assumptions, things about, okay, my relationship is linear between two variables. Or the distribution in my data is normal. Okay? But as you guys probably know, much of things in life are not perfectly linear or are not normally distributed. You can get things like heavy tails, or outliers, or non-normal distributions. Okay? And so to do things like run a model that assumes linearity or assumes normality on non-normal or non-linear data can give catastrophic results. Okay? And you can think about it with things like the failure of a very large hedge fund in the U.S. about 10 years ago for long-term capital management. Okay? You can think about it, things like the flash crash you may have heard of a year ago, where the stock market in the U.S. dropped by 10% in a matter of minutes because there was these abnormalities in models that were running trading systems. The second one, though, that's very important, is the ability to identify rare events or low incidence populations. So what's a rare event? Right? Think about being an insurance company. And trying to have to model or think about the probability of having an earthquake plus a tsunami plus a nuclear meltdown in Japan. It's a pretty rare event. But if you look at over history, things like that do happen over time. If you collect all of the events that have ever happened, there are these catastrophic outliers that are many, 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 many standard deviations from normal, from the average. If you simply take the average of the distribution, you miss out on those things. Same thing with low incidence populations. Healthcare field, illnesses. Things like in healthcare, a very small number, very few people within the population actually consume most of the healthcare dollars in most nations worldwide. Okay? So the ability to not aggregate them together, but to actually study these micro-populations or these very rare sets of people and be able to target and provide treatment and proactive treatment to them by pulling them out and giving them special care has the potential to dramatically reduce healthcare costs worldwide. Okay? And then finally, it's really about understanding and studying what I call the microstructure of data. Think of being is there anybody who's a marketing field in here? Anybody studying their customers? Not really? Well, one of the things that's important is that all customers don't behave the same. So again, by analyzing and using large data sets, you can understand what are the microgroups within here to be able to do things like target ad campaigns at small groups of people specifically for their interests. Okay? And what it all really boils down to is to generate better predictions. Okay? And of equal importance, for those predictions, be able to gain deeper insight into the results that you achieve with these models. So how do we put this into practice? Historically, there's really been two big problems with analyzing this big data. The first one is capacity, and the second one is speed. And so what do those two mean? By capacity, we mean traditionally, in order to analyze your data, you had to be able to fit all of it into your system memory, into RAM on your computer. And that was a big deal. Yes, hardware costs are coming down, memory costs are coming down, but it's still very expensive. And it's still more expensive than hardware than disk. But even if you can fit it all into memory, there's still limits on what can be done. So if you build a very, very big server and put terabytes and terabytes of memory, if the technology cannot do the calculations in parallel, take advantage of modern computing architectures, it becomes so slow that your analysis becomes useless. Okay? So what we've had to do with R is to tackle both of these challenges, to implement technologies to remove both the capacity barrier and implement things like external memory algorithms, i.e. where part of the data can be stored on disk and part of it can be analyzed in your system memory. But then also to do parallelization, okay? And do things like multi-threading, distributed computing, multi-core, leveraging things like Hadoop and MapReduce to take advantage of these modern computing architectures. So just to explain a little bit what this is, the basic idea behind